Hello, good morning everyone. Thank you for being here. My name is Juan Carlos Correa and I am going to talk with you about the exploration of synergy between motorists and motorcyclists in urban traffic. Motorcycles are now more commonly used for urban mobilization than ever before. Here in this picture, we are seeing the countries and regions where motorcycles are commonly used as means of transportation. Just to take a local example, here in this picture we are seeing the statistical sales of motorcycles and vehicles in Venezuela from January 2020 to December 2014. And it can be seen that the use of motorcycles is almost 4 times higher than the use of cars. And in other countries, its use is even more pronounced. It must be noticed that the competitive prices of motorbikes and their advantages to move faster than cars in urban traffic are two obvious reasons that explain the popularity of motorcycle use. And because of these reasons, the practice of motorcycle lane sharing is now well known in larger cities. This practice occurs when motorcyclists ride in between the lanes of stop or slow-moving vehicles, despite the fact that it might jeopardize traffic safety on the road. This practice of mobilization, induced by vehicular density and economic factors, presents a behavioral interaction between motorists and motorcyclists who act as elementary components of a phenomenon which has its own peculiarities at both the macroscopic and the microscopic scale of analysis. But how can we study this phenomenon? Well, initial approaches, also known as macroscopic models, focus on the fundamental relationships between flux, speed, and density, as we can see in this picture, and the relationships between these metrics. A second group of approaches, known as microscopic models, focus on the relevant variables that allows us to understand the interaction between road users by analyzing the specific individual behavior of each road user. Despite the adequacy of microscopic approaches to analyze the interaction between road users, the observation of these variables in real traffic demands a lot of instrumentation in natural settings, which can be costly. And here lies the utility of agent-based simulations as handy research resources. An intelligent agent is a software-hardware entity that resembles some physical or biological entities by mimicking their behavior according to some rules predefined by a system modeler. And what does this have to do with synergy? Synergy is commonly understood as the creation of a whole that is greater than the simple sum of its parts. And in the case of urban transportation, synergy can be observed by combining microscopic approaches with agent-based models of heterogeneous traffic. The heterogeneous traffic is characterized by the interaction of motorcycles and four-wheeled vehicles driving without lane discipline. The absence of lane discipline consists in the vehicular movement that is influenced by the presence of vehicles in the front as well as on the sides. And this leads to a complex traffic behavior, and it cannot be analyzed by using conventional traffic variables such as time headway and space headway, that is, the bumper-to-bumper distance that separates two vehicles. So we need another set of variables that allows us to understand synergy between road users in traffic. Here stands the importance of the not well-known concept of area occupancy. Area occupancy is based on the concept of occupancy, which is defined as the percentage time any arbitrary road section is occupied by a vehicle over a given period of time. The calculus of area occupancy is as follows. Area occupancy is represented with the lowercase Greek letter rho. The capital letter O stands for occupancy. The lowercase letter w represents the width of the vehicle, the uppercase letter W is the road width, lowercase d is the length of the road section under consideration, and the uppercase T is the observed time period in seconds. In this equation, the numerator value takes care of the occupancy time, similar to occupancy, the amount of time a vehicle with a given area is spending on the road section under observation. Its value will depend obviously on the traffic composition and speeds of the vehicles. Now, since motorcyclists have a faster occupancy time due to their possibility of percolating through stop or slow-moving vehicles, the efforts of measuring heterogeneous traffic flow present us an interesting opportunity to examine the synergy between road users. And where is the empirical evidence? Well, Correa developed an agent-based model to estimate the quantitative impact of motorcycle lane sharing on motorist behavior. In this model, three agents are comprised: the road, the motorist, and the motorcyclist. These agents interact in a non-toroid two-dimensional virtual environment represented as a map with a coordinate system whose origin lies in the upper left corner. The physical dimensions of this map were 40 meters of height and 400 meters of width. The physical dimensions of the road were equivalent to a two-lane avenue with a length of 400 meters. The width of each lane was fixed to 4 meters. The total length of a single lane is constituted by 100 cells of 4 meters square. This layout is depicted in this figure. In this model, motorcyclists choose a lane to drive on and then do not attempt to change the chosen lane. Motorcyclists drive at speeds that are higher than those of the motorist, which is a common fact which has been already validated in previous studies. The results showed that the presence of motorcyclists reduces significantly the frequency of lane changes of motorists while increasing their frequency of acceleration-deceleration maneuvers, without significantly affecting their average speed. That is, motorcyclists corral motorists in their lanes, limiting their ability to maneuver and increasing their acceleration noise. These results were also confirmed in observations of real traffic. In this picture, we see the statistical differences between lane-changing maneuvers of motorists interacting with and without motorcyclists. Yellow boxes represent the maneuvers of motorists in homogeneous traffic, namely when they do not have to interact with motorcyclists. Blue boxes represent their maneuvers when they do. The gap between these boxes shows us the corral effect produced by motorcyclists. Another interesting evidence was obtained in India. Mallikarjuna and Rao estimated the heterogeneous traffic flows by using a sophisticated video analysis software to collect traffic volumes and composition by automatically identifying types of vehicles on the National Highway 1 connecting New Delhi and Amritsar. They found that when more vehicles with low vehicle area or vehicles with large areas were traveling on the roads, it was observed some differences between the values of occupancy and area occupancy in some moments of the observation period. In this figure, for instance, we are seeing the variations of occupancy and area occupancy over time. Note, however, that the curves are quite different. We finally have another study about the effect of traffic composition on flows. As part of his doctoral dissertation, Lee observed that the worst traffic corresponded to the scenario of 100% of cars, while the best one corresponded to the scenario of 100% motorbikes, and the different mixed compositions occupied an intermediate position between these two homogeneous traffic. As final comments, we have to say that the synergy in urban traffic consists in the rise of the road capacity because motorcyclists can exploit the road space by filtering through a slow-moving flow, using the clearance between two parallel cars or the possibility to weave in and out of a stationary flow via the safety margins between vehicles. However, due to the difficulties associated with measuring heterogeneous traffic flow in natural settings, traffic management usually relies on the assumption of an homogeneous traffic. Here we have seen the importance of area occupancy as a metric for measuring heterogeneous traffic streams that give us a more precise idea of traffic dynamics. However, this measure needs further validation under various traffic regimes, like free flow or congested traffic. Since vehicle dimensions are very crucial in realizing the area occupancy, there's a lot of work to be done in this direction. In agent-based simulations, we have seen that the overall traffic flow improved when the composition is not completely homogeneous. A fruitful venture in the near future should take into account when it is convenient to restrict the practice of motorcycle lane sharing and when not. Another fertile orientation is to examine under what specific conditions works this synergy, namely, to examine the effect of lane width, number of lanes, etc. The future of traffic management depends on our knowledge about the interaction of road users, which clearly welcomes the approaches of complexity sciences. Well, thank you so much for being here with us at the World E-Conference on Complex Systems and the E-Session of Interdisciplinary Studies of Synergy.